In this video, we will discuss the problem party in town. The problem says that Geek Town has n houses which are numbered from 1 to n and they are connected with each other via n-1 bidirectional roads. So let's suppose that if n value was given to me as 3, so let's say there are 3 houses, right? So they will be connected by how many number of nodes? They will be connected by n-1 roads, right? So this road, let's say this road, right? Or you can say that if these 3 houses were there, so they could also be connected like this or this, and you can see that from this house there is a path to the this house, right? So basically this means that you can observe that from any house there is a path to every other house that is there lying in the geek city, right? And this is nothing but the representation of tree when you have n nodes and n-1 edges connecting them. So this indicates nothing but the concept of trees, right? So you can reach every house. The problem says that what you have to do is you have to find the minimum distance such that the party can be done. Now what is this minimum distance? The problem says that you have to find the house from which the distance to the farthest house is minimum possible, right? So you have to iterate from every house and you have to check that what is the maximum distance, and for every house you have to do the same thing and you have to minimize this particular distance. What does this mean? So let's say if this house is there, this house and this house, right? So let's say these houses are connected like this, right? If these houses are connected like this, so you will start from this house, right? And you will say that okay, what is the maximum distance? So for this house the distance will be 1, and for this house the distance will be 2, right? From the starting house, this house is at a distance of 2, so you'll say that the farthest house at a distance is at a distance of 2 from this leftmost house, right? Or let's say if I start from this house, right? So if the party is in this house, so what will happen? What will the maximum distance? So this house is at a distance of 1, this house is also at a distance of 1, so the maximum distance will be 1, right? And now let's say that if we keep the party in the rightmost house, right, in this particular house, so in that case you will say that okay, this house is at a distance of 1 and this house is as a distance of 2, right? So you can see that out of these distances, that is 2, 1 and 2, the minimum distance out of these maximum distances for every node or for every house, you try to find the maximum distance, right? Maximum house which is at the maximum distance, right? House which is at the maximum distance you try to find. So for the leftmost the maximum house distance was 2, for middle house the maximum distance seemed to be 1, for the right house the maximum distance seemed to be 2, and you have to print the minimum, you have to return the minimum out of these distances. The minimum distance is nothing but 1, right? So how will you do this? So basically what you can do is you can as you can see that we were applying just nothing but a depth first search, right? You just need to apply a DFS traversal. You need to apply a DFS traversal for all the n nodes, right? For all the n nodes that are lying in the tree, for all the n nodes, for the ith node, let's say I start from 1, I is lesser equal to n. So for all the n nodes you need to apply this DFS traversal and you need to check what is the maximum distances, and you will always keep on updating the minimum every time after the DFS call, so that you can get the minimum distance out of all the maximum farthest distances for all the nodes, right? So let's try and write the code. So what I'll have is I'll have int answer is equal to nothing but int maximum, right? I'll initialize my answer as int maximum, and what I'll say is for int I starts from 1 and I is lesser equal to n, and what I'll do is I'll do I plus plus, and then I'll be running for all the nodes, right, starting from the node number 1 till the last node, and what I'll say is that vector int, right, I'll say the visited of what n plus 1, that because I'll have a visited array, I'll have it as n plus 1 because the nodes are starting from 1. I'll initialize all the nodes as 0, and then what I'll say is I'll say that maximum distance is equal to 0, right? So I'll say that for this particular node the maximum distance will be 0, and since I'll be finding the maximum distance for every node, so I'll always say that the maximum distance I'll declare it as global, right? Because I'll be finding the maximum distance from the ith node for every node, right? For every ith node I'll be finding it, right? So that's why I'll have it, and then I'll run a DFS for I, right? I'll pass the node I, I'll pass the adjacency list, I'll pass the visited array, and I'll pass the node number 0, right? And then what I'll say is that after it's calculated in my answer, so I'll say that answer is equal to nothing but minimum of answer comma what answer is equal to nothing but minimum of answer comma maximum distance, right? And like after I'm getting, right, max d is giving me what? Max distance is storing but nothing but it is storing the distance of the farthest node, from the ith node, right? From the ith node, right? So that is what it is showing. So every time I'll run a DFS and maximum distance will get updated, right, for the ith node, and I'll keep on updating that okay, whatever maximum distance I'm getting, what is the minimum out of them, right? And I can say that I'll return the answer as well, right? After this part is done, so I definitely need to do one more thing. I need to have a maximum distance, like I need to have a DFS function, right? That will help me to traverse through the complete tree starting from the ith node. So I'll have what? I'll have, let's say, int vertex. The current vertex, let's say, is v, and I'll also have the vector of vector int ampersand adjacency, right? I'll have the adjacency list. Apart from the adjacency list, I'll also have the visited array, right? Vector of int ampersand visited array. Apart from this, I'll also have the current distance, right? So maybe what I can do is I can mark current int current, that means the current distance, right? So what I'll be doing is I'll say that, okay, I'll mark the ith node or the current node as 1, like marking it as visited, and I'll update my maximum distance. So maximum distance is equal to nothing but maximum of the maximum distance comma the current distance, right? So that is what I'll be doing, and after this I'll iterate through the adjacency list of the node, right? Of the vertex v, I'll iterate through its adjacency list. So I'll say that int I is to, like, I will help me to iterate through all the nodes. So what I'll say is that I'll iterate through all the nodes present in the adjacency list, and I will say that if the visited of I is equal to 0, if the ith node is not visited in the adjacency list of the current vertex, right? So in that case I'll have to run a DFS call, right? So I'll say that I'll pass I comma the adjacency list, I'll pass comma the visited array I'll be passing, and I'll pass nothing but the current plus 1, right? Because the distance will increase by 1. So that is how the DFS call will be done, right? And let's try and compile this and see if it works on the samples, or we have any compilation issues. Seems to work on the samples. Let's quickly submit it and see if it gets accepted or not. So you can see that it was able to pass all the 12 test cases, right? Now talking about the time complexity of this particular approach as well as the space complexity. So what you can understand is that the time complexity of this particular approach, if from one node I'm visiting all the other nodes through the help of DFS, right? My DFS function for one time, it takes order of n time, right? For one traversal of DFS, it takes order of n time because it is traversing through all the nodes, right? So for one node, for one of the nodes, it takes order of n time. So for all the n nodes, it will take n into n time, right? So that's nothing but order of n square kind of an approach, right? Apart from this, talking about the space complexity, so since we are not using any extra data structure, so that's why the space complexity will be 1, assuming that you are not considering the stack space, right? Thanks a lot for watching this video. If you understood the explanation completely, make sure to hit the like button. Thank you.